Hello everyone, I'm Ravish Kumar, a deep learning engineer and a machine learning course instructor on Ninja algorithms. In this video, we are going to discuss the essence of the machine learning course that we have just launched as a live lectures on our Ninja algorithms platform. And we are also going to discuss what exactly we will be discussing in these courses. So let's start with one particular question which is very frequently asked, and you might also be thinking the same question. So let's answer it in a greater detail. So why to learn machine learning in the era of ChatGPT and Gemini? Definitely, ChatGPT and Gemini are the new trends in the field of artificial intelligence and machine learning. But these models are based on the transformers. But to develop the transformer models, you still need to know what exactly uh, are the fundamentals of machine learning. These fundamentals are not going to change. Like understanding the fundamentals means, like suppose even if you will build the chat gpt models, you still need to know whether these models are supervised or unsupervised, whether these are classification models or regression models, or some other models, whether these models are parametric models or unparametric models. Even to train these models, which kind of data set will be required, why these models use 65 trillion tokens. So what is world tokens? Why can't machine learn or understand the text? How exactly we can transform the text to understand, to make machines understand the text? So these are the fundamental things that still need to be like known to us to develop these kind of models. So that's why we are learning machine learning as a fundamental theory of to start with. The second thing is like high interpretability and explainability. So these models are very huge. Once you will know the interpretability means, like suppose your model is explaining why it is giving certain kind of prediction. Like suppose if you have made a robot, then it should explain and robot for this for the medical surgery. Suppose if some kind of mishap happens, then it should say that because of the blood shortage, the mishap happened, or because of something like suppose lack of electricity, this happened. So these kind of explanations your model should give. Otherwise, like these are nothing but the feature values that we are feeding into the models. We can definitely say based on the feature values, like if some kind of feature values are missing, in that case model is performing in an absurd manner. But this kind of flexibility is not available with the chat gpt and gemini models. Okay, compute effective, these models are very huge even in the gbs. So to execute and to store these models, we require a high memory computing power. So that is something like that is still a kind of the future of AI is not on the cloud. The future of AI is on the embedded platforms, like on the drones, on the smaller cars, on the autonomous vehicles, or even on the planes. These kind of things we want. We definitely do not want our models always on the cloud. So that's the thing. Like compute effective is a kind of the thing because of which machine learning is still relevant. That data requirements. Data requirements is something like these models require a very huge amount of data. And in case of machine learning, they can easily provide you the results with a smaller, fewer number of samples. Data privacy. Privacy is a most relatable concern these days because data goes from one system to another system. How it is being used, we don't know. So in that case, these Chat GPT and Gemini models are using our data. So, but in most of the cases, many frequent OEMs or many bigger companies don't want their data to be leaving their servers. In that case, they develop a smaller memory footprint model so that they can execute those models on their servers or their platforms or their hardware. So that's why still the machine learning is going to be relevant. So I have explained the essence of the machine learning course in the era of ChatGPT and Gemini. So let's quickly discuss why exactly and what exactly we are going to discuss in this particular machine learning course. Okay. So before going to that point, let's discuss why exactly we have designed our curriculum in the same way which is currently designed. The thought process behind designing this course was we discussed a lot of students and machine learning professionals and try to understand their requirements from a machine learning course. Students said that they require some kind of fundamentals so that they can clear machine learning interviews, their grasp on the fundamental theory and maybe like some kind of techniques that are being used in the fundamentals of machine learning, which can help in clearing the courses in their engineering courses in their semester as well. So that's why fundamentals were required. And they also wanted some kind of interview preparation tips. But when we talked to the professionals, they said like they wanted some kind of tips to improve the performance of machine learning models. Performance can be increased by two ways: either increase the accuracy and or maybe you can say increase the decrease the latency. Latency means like how much time a model is taking to give you the predictions. Whenever you are putting one particular input, then it should quickly give, or it should prompt to give you the answers very quickly. So that is latency. So if you will try to improve the latency, so you need to compromise with the accuracy. So these kind of techniques they wanted. Like, and also they wanted what after the model development. There is some kind of deployment. They wanted some kind of support so that they can showcase their developed model. So based on these needs, we actually have curated an end-to-end curriculum, which is based on both the things, like the like covering the fundamentals, also covering the interview preparation, also covering deployment and improving the machine learning model performance as well. Along with that, we are discussing all the popular machine learning algorithms with their mathematical analysis. So let's understand in the phase-wise manner what exactly we are going to discuss in this course. We are definitely going to discuss the fundamentals, like what is the cost function, what is supervised and unsupervised. We will be dividing the machine learning models on 5 different bases. Like suppose based on the nature of the problem statement, we will be dividing our machine learning models as classification, regression, clustering, these kind of techniques. So, and once these fundamentals will be done, we will also be learning like fundamentals like what is the difference between artificial intelligence and machine learning, what is the difference between traditional programming and machine learning, what how exactly a non-living thing which is machine starts learning, how exactly you can say that the gradient descent helps us to find global minima in of the cost function. These kind of things we still need to know to be very confident in clearing machine learning interviews. Once that fundamentals is done, we will be going towards the data part. Data is something like very important for machine learning. Even you can find many different like bigger names in the field of machine learning or deep learning, like Andrew Ng. They have started talking about data intensive machine learning courses. So that's why to cater that we have included all three forms of data, which is text data, image data, and numerical data. All three forms of data will be discussed with their EDA, feature analysis, feature require like feature engineering, and exploratory data analysis is the EDA. And we will be discussing their pre-processing techniques, their visualization techniques as well. So these are the things that we are going to discuss in the data part. Once that is done, we will be going to discuss model improvement section, how you will decide your model is suffering from one particular problem. One particular problem may be whether your model is overfitting, underfitting, whether your model has high bias, low bias, whether your model is suffering from low variance or high variance, how exactly you will be achieving the case of low variance and low bias case. What is the bias variance trade-off? So these kind of things, how exactly you will apply the regularization. So these kind of techniques definitely help us to improve the accuracy of the machine learning models and then decide which model will be going to perfectly fit our data. So these are the things that will be specifically designed for machine learning professionals, but still professionals after teaching like many different batches. So they professionals gave the feedback that they learned a lot from the fundamentals also, because most of the time fundamentals are some like uh, given a less weightage, or maybe they miss some kind of very minute details that are present in the theory. So that's why fundamentals is still required, data is still required, and the model performance improvement. Once that is done, we are going towards supervised and unsupervised algorithms like linear regression, logistic regression, SVMs, random forest boosting techniques, and like decision trees, naive-Bayes algorithm, KNN. All these kind of algorithms will be discussed. Once that is done, we will be going towards the unsupervised learning algorithms, which requires clustering like K-means plus plus, PCA, and all these kind of things we will be discussing. But not only the algorithms, their mathematical details, but along with that, we require some kind of hands-on. And that hands-on will be giving us much confidence in clearing machine learning interviews. You will be like learning the thought process behind designing a particular project. And that thought process is being checked in the machine learning interviews. That is the essence of, that is the most beautiful thing that we have covered in this course. So you will be learning the thought process to design the machine learning project end-to-end pipeline. And once that is done, you will be confident enough to solve any of the problem that will be given to you. Okay, once that is done, we will be like developing one project on each of the algorithms that we are going to discuss. Okay, and that project, out of them, one project will be like used to create a web shareable web application that can be like shared with the help of one link. And you can share that link to clients, friends. They can use your model directly on using that link on their systems, but the code will be running on your system. So this is something, a new addition into the course, and it is very useful for students and machine learning professionals. So I hope you will learn a lot in that batch, and it is going to start soon. So wish to see you there. Thank you.